Dear student, welcome to the fresh topic, that is types of chemical bonding. As you know, this chapter is very important because this chapter is the base of organic chemistry, inorganic chemistry, physical chemistry, all the three types of chemistry. So, let us study the types of chemical bonding and what happens, how many types actually. So, when we go to class 11th, so many types are there, but in this class right now we study only 4 types of chemical bonding. The first one is ionic bond, which is also known as electrovalent bond. The second one is covalent bond. The third one is coordinate bond, which is also known as dative bond or dipolar bond something. And the fourth one is hydrogen bond. So, these 4 types of bond we will study here in this particular segment, where in this lecture, today lecture, we will discuss only ionic bond. Okay. So, the types of chemical bond, so which type we are studying right now, that is ionic bond. Okay. What happens? Ionic bond says something with the name only, like bond between ions. What happens? This type of bond forms between positive ion and negative ions, I mean cations and anions. What happens? As you know how cation forms, when any element will lose electron, will donate electron to someone, then it will convert into the positive charged ion, that is cation. Okay. And that type of element is known as metal. Okay. If any element is gaining electron, then that is non-metal. So, ionic bond is the bond formed between metal and non-metal, in which one element will donate electron and other element will accept the electron. Let us see the definition of ionic bond. Bond which is formed by the complete transfer of electron, okay, between the metal and non-metal is called electrovalent bond or ionic bond. See how. Suppose I am taking any metal like sodium, okay, and taking any non-metal chlorine. So, what happens? Chlorine has 7 electrons in the outer shell, in the valence shell. Okay, 7 electrons. If chlorine will get 8 electron, chlorine will have octet, will have complete octet, because completing 8 electrons in the valence shell is called octet, octet completion. So, and then it will become stable, chlorine will become very stable. Okay. Sodium has 1 electron in the outermost shell. What happens? Sodium donates electron to chlorine, right? Okay. And chlorine will receive the electron. Sodium is a metal, okay, and chlorine is non-metal, right? What happens? When sodium will donate 1 electron to the chlorine, sodium will convert into Na plus, and once chlorine will receive 1 electron from the sodium, then chlorine will convert into Cl minus. Okay. Now, tell me, positive and negative, they will attract to each other, yes or no? So, what happens? Attraction takes place between the positive and negative, and after that they come close to each other and then they form NaCl. So, which type of bond is in NaCl? Name is ionic bond, okay, because this type of bond formed between ions. So, what are the ions? Sodium ions and chlorine ions, I mean chlorides. Okay. So, this is how ionic bond forms. Let us see the next information about ionic bond. Factors affecting or factors influencing the formation of ionic bond. Dear student, there are 3 factors which affects majorly the formation of ionic bond. The first factor is ionization energy. Okay. So, what happens? What is ionization energy and how it affects is a question. So, what happens if any atom is there? Okay. Suppose I am talking about the sodium atom. So, sodium atom, this is solid in nature. What happens? We convert this sodium into gaseous state. How to convert is the different question, okay, not from the bonding. So, sodium solid converted to sodium gas. Now, we remove 1 electron from the sodium and converting it into sodium cation in gaseous state, right? Okay. Wait, understand, amount of energy is required to remove electron from any atom, yes or no? Because you know that the nucleus will hold the electron. There is attraction force between the nucleus and the electron. So, if you want to take out the electron, then you should supply some amount of energy. The minimum amount of energy required to remove an electron from any gaseous isolated atom is known as ionization energy. Already we discussed in a few chapters back actually, okay. Alright, so we got sodium cation. How? I told you the process. It is not like directly from sodium solid we remove electron and we get Na plus. No, it is not like that. At first we convert the sodium solid into sodium gas. Okay. So, now I told you what is ionization energy. Logically you tell me one thing here. Okay. Okay, alright. See the next point to understand better. So, let us see now. Lesser the ionization energy, if I supplied less energy to the system, okay, and in less energy only it is releasing the electron, it is good for us. Okay, we should always use less energy. Okay, system should consume less energy to do the good thermodynamic process. Okay, so lesser the ionization energy, greater is the ease of the formation of cation. Wait, understand. Suppose I have two cation, not cation, I have two atom A and B. Okay. Only in 10 kilocalorie A will release electron, but B needs 80 kilocalorie to release one electron. So, very easily bonding is possible here because it will easily convert into cation. In very less energy it is converting into the cation, but it is demanding very high energy to convert into cation. So, this process is easy, yes or no? So, A will form ionic bond faster than the B because A will convert into ion faster than the B. Getting or not? That is what I said. Lesser the ionization energy means in less energy only if it is releasing the electron, then it is very easy to form the cation, very easy to form the ionic bond. I hope you understood my point. Okay. Let us see the second factor now. Electron affinity. What is electron affinity? What happens? A or B or Na is atom, I mean metal. So, metal will lose electron and metal will convert into cation. And what about the non-metal? Non-metal will receive the electron. So, electron is adding to the non-metal and electron is losing by the sodium, I mean metal, correct? Okay. So, again there is an energy factor to add the electron in any atom. Definitely one energy factor is here to bring out the electron, and one second energy factor is to add the electron in the non-metal also. So, it is defined as amount of energy released when an atom, I mean when an electron is added to the isolated gaseous atom of element. Wait, understand. If you add electron in the chlorine, okay, then what happens? Energy will release. If you remove electron from the sodium, energy will be absorbed by the sodium. Okay. So, whatever the energy is releasing by the chlorine during the addition of one electron, that energy is called electron affinity, correct? Okay. There is a bit similarity in electron affinity and electron gain enthalpy and bit difference also. That is not our main question here. So, I explained electron affinity, that is energy released during the addition of one electron. Okay. What is ionization energy? Energy absorbed during the releasing of one electron, and here due to addition of one electron energy will be released. Due to removing one electron, okay, energy will be absorbed, right? Okay. How electron affinity affects? Let us see that. Higher the energy released, okay, I mean more electron affinity, okay, easier will be the formation of an anion. Why? Wait, understand. One thing you must remember, that if any system has more energy, it has less stability. Okay. So, you always try to, if any system is absorbing energy, demanding energy, you always try to give less energy. Okay. If any system is releasing energy, you always try to release more and more energy from that system, right. So, if any non-metal is releasing more energy during the ionic bond formation, it is very good. If any metal is absorbing very less energy to form the ionic bond, it is very good, right. Okay. So, higher the energy will be released by the chloride, I mean the chlorine, okay, the easier will be the formation of anion, easier will be the formation of ionic bond. So, electron affinity, what is electron affinity? I told you that, okay. How it affects? We understood that. Let us see the third factor, that is lattice energy, okay. What is lattice energy? See what happens, it is defined as the energy required to convert 1 mole of ionic solid, okay. Any 1 mole of ionic solid we have like AB2 type or AB type, does not matter, it is ionic solid actually, okay. And we want to convert this ionic solid into constituent gaseous particles. Its solid to constituent gas conversion is known as lattice energy. Actually, lattice energy has very detailed concept in chemical bonding only in class 11. Here we study about the Born-Haber cycle also, and so many question arises from here. Detailed discussion is in the class 11 chemical bonding chapter. Okay. Let us see the point how it affects the bonding formation. So, higher the lattice energy, greater is the tendency of formation of ionic bond, okay. See, mainly what is lattice energy, what happens, sodium plus and Cl minus, okay, they come close to each other and they release their energy, okay. If 1 mole of crystal I am talking about, then the amount of energy released, that is lattice energy mainly, okay. So, what happens if more energy is releasing, see what I said, energy releasing when positive and negative are coming close to each other, energy is releasing. So, if more energy will be released, more stability will be inside the system, yes or no. So, if higher is the lattice energy, it is good for us. Any energy which is releasing by the system is very good, okay. We should release more and more energy, and any energy which is absorbing by the system, that is not good. We should try to give less energy, okay, as lesser as possible, okay. So, if the lattice energy is very high, it is very good for the system and ionic bond formation will be very much easier and it is very stable actually, okay. So, this is how lattice energy affects, okay. Let us study some other factors like properties of ionic compounds. So, what happens, any electrovalent compound like sodium chloride is also electrovalent compound or ionic compound, you can dissolve it in water. Of course, you have dissolved the NaCl in water so many times, okay. So, you can dissolve in the water, electrovalent compounds are soluble in water, okay. But it is very difficult to dissolve the electrovalent compound in oils like kerosene oil or petrol, there it is difficult to dissolve. Why? What is the concept? The concept is like dissolves like. This is polar compound NaCl, okay. So, polar dissolves in the polar and water is also polar compound. So, polar dissolves in polar like that, okay. Alright, let us see the next property of ionic compound. Ionic compound do not conduct electricity in solid state. Suppose you have sodium chloride, I mean salt in your plate, okay, and you bring electricity from somewhere through the wire and put it on the, means bring in contact with the salt, you touch the salt, no problem, okay, there will not be any electrical conductivity. But if you dissolve the sodium chloride, I mean salt in water, bring the current wire there in contact of that solution, now touch the solution, do not touch, okay, otherwise you will feel current. So, do not touch. What I am saying is, in molten state, in solution phase, NaCl will conduct electricity or ionic compound will conduct electricity, but in solid state it does not conduct electricity, okay. This is what I wanted to say. Let us see the next property of ionic compound now. These compounds are brittle and breaks into small pieces easily. What is the meaning of brittle? See, brittle means suppose you have any glass, okay, any glass like whiskey glass, rum glass or wine glass, okay, or like water glass simply, okay. So, you just drop that glass on the floor, what will happen? Glass will break into so many pieces. That phenomena is like, that nature is like a brittle nature, okay. So, this is what the brittle is. You leave your mobile from the 3rd floor till the ground floor, what will happen? your glass will break, I mean either your tempered glass or your screen will break, that nature is brittle nature. So, ionic compound shows that type of brittle nature only. Okay. What happens? It is very difficult to break the bonding between sodium and chlorine. Why? Because there is a huge interaction, I mean electrostatic force of attraction between the sodium and chlorine. Very strong attraction force is there. To break that bond, high amount of energy is required. That is why ionic compounds have high melting point and boiling point. Okay. So, what happened? We studied the what is chemical bond, I mean what are the types of chemical bond, okay, and what is ionic bond definition, what are the factors which affects the ionic bond formation, and what are the properties of ionic bond. I hope you understood this lecture. Thank you for watching.